All right, one thing I'm not a fan of these books is the terminology is good, but I think before we start, we should know what the difference between these two things are. So I'd like you to go to the summary first. I just want to talk about those two terms. We did mention them a little bit. You know, what is a rational number? And your response shouldn't be, it's a number that's rational, right? You can't use the word in its definition. Ian? Yeah, so a rational number can be written these ways, and I would add these to your notes. Okay, if it can be written as a decimal that repeats or terminates, means it stops, it's rational. So if it's written as a decimal, it needs to repeat or stop. 0.5, for instance. 0.3 repeating, for instance. If it can be written as any fraction, it is rational. And then, of course, any whole number is also rational. And that leaves us to the other end of the spectrum, irrational. Again, definition should not be, it's a number that's not rational. Okay? This one cannot be written as a fraction. And as a decimal, there's no pattern. It doesn't repeat. It doesn't stop. So it still can be written as a decimal, but it goes on forever. Okay, up here, these are all rational numbers. Fraction, 6 divided by 3, fraction, it's just 2. Fraction, decimal would be 0.3 repeating, it's fine. Square root of 9, what's square root of 9? 3, that's a rational number. Square root of 16, square root of 10, both come out nice. 4 over 10, that's fine. Okay, opposite of that is on the bottom. What's the square root of 10? Something. Reason you don't know, doesn't come out nice. Okay, if you do it on a calculator. You might say, well, it looks like it stops. No, the calculator only goes so far. That number goes on forever. No pattern, no repetition. Square root of 3, same thing. Know what square root of 3 is? No. Why? It's irrational. Know what square root of 5? No. Irrational. Pi. Doesn't repeat, doesn't stop, no pattern. Irrational. Okay, so we need to know what those things are here before we go too far. These are rational solutions. Addie Chase, what do you think for 1? 6. I agree with that. 2. Zoe. Yep. So first one I took the square root of 36, got 6. So I'm looking for the square root of 9 and square root of 4. Perfect. Square root of 1/4. Wyatt.
1/4.
Square root of 1, square root of 2, or square root of 4.
1 over 2.
Perfect. 49 over 25, Taylor. Square root of 49, square root of 25, perfect. On we go. Draw 3 squares, different sizes, vertices aligned in the grid. Find the area, find the side length, find an equation. All All right. Well, let's draw 3 different squares. And answer the questions. All right, first one. Area. 4. Put it right inside. Side length. 2. Middle one. Area.
1.
Side length. Yeah, with the last one. Could do it like we have done before, right? If this whole thing was a square, the area would be 4. What's the area of each of those little triangles that are missing? 1 times 1 divided by 2. 1 times 1 is 1 divided by 2 is a half. Half, 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 half. Means the area of this thing is 2. Probably could see that. Each one of these is a half of a square. I have 4 of them. What's the side length? What did I do to the area to get the side length on the first one? How did I go from 4 to 2? How did I get that? No. I mean, if I got an area that's 25, I'm not going to divide it by 2 to get the side length. I'm taking the square root, right? If I have an area that's 36, I'm going to take the square root, get 6. Square root of 4 is 2, square root of 1 is 1. What do you think I got to do here? Of?
2.
Do you know it?
You
Can't.
It's irrational.
So I'm going to leave it as the square root of 2. Process is the same even if it doesn't come out nice, even if it's irrational. Just leave it as the square root of 2. That is called the radical form. That is exact. Anything other than that would be a approximation because that decimal doesn't repeat and it doesn't stop. So how do I get side length and area? Well, to get my side length of a square, I am taking the square root of the area. That is true for every square. If a square is 100, you take the square root of it to get the side. Question number 3, I'd like you to read through that. See if any of those work. You can use a calculator if you want. Do any of those make it true? That number squared equals 2. Give you about a minute. Lily, what do you think? 1 work? 1 squared, is that 2? No. That would be 1, right? 1 times 1. Gerhard, does a half work? Half times a half? That's 2, right? No? What is a half times a half, just out of curiosity? 1 times 1 and 2 times 2. Yeah, that's not 2. 3 over 2, Parker? Is that 2? No? What's 3 times 3?
9,
And 2 times 2?
4,
Yeah, that don't work. That's, what, 2 1/4? 9 divided by 4? 7/5, that must be it then. Wyatt, what do you think?
Nope.
No? What's 7 times 7?
49.
And 5 times 5? Yeah, that's less than 2. That's close.
Really close.
50 divided by 25 would be 2. But that's not 2. So why can't we find it?
It's a rational number.
It's irrational. Okay, again, proving the definition. Okay, last one we're going to look at here. Find some rational numbers that are close to 2. Okay, well, you did over here. Oh, close to the square root of 2. Sorry. That would be 7/5 then. So, square root of 2, just to prove it. Come on. Stop. Is about 1.414. Again, that goes on forever. So give me some rational numbers that are close to 1.4. Here's the proof, 7 divided by 5. That's pretty close. That's 1.4. Not exact. I suppose you could double it. 14 divided by 10 would be the same, 1.4 still. Would you say 1.5 is pretty close here?
yeah,
You could do 1.5 or 3 over 2. That's pretty close. Could do 1 4/10. That's pretty close. All right, so find a rational number that's exactly square root of 2.
no,
Can't. Exactly right. Can't do it. All right. Again, know those terms, know the difference between them, and don't be scared of a square root symbol. Assignment is 1 through 6. Please draw an arrow on page 35 to make sure you hit up number 6 so you don't forget that. Going to be a lot of square roots here going forward. Rational, irrational. Number 1, that's what it's asking you. Is it rational? Is it irrational? Put a little R or I by it. That's all you got to do. Okay, 1 through 6 for Monday, please.